EDMA163 Assessment 1 Mathematics in the Real World by Sarah Jane Zuzek. Hello everyone. For this assignment, I interviewed Chris, who is an arcade technician. Let's start off with the mind map. As you can see, this is my mind map of the maths I thought an arcade technician may use in their job. Let's go to the interview. When diagnosing a faulty machine, what mathematical methods do you use?
This depends on the type of fault. If it's an electronics fault, we use the formula P equals V times I, where P is power, which is measured in watts, V is for voltage, measured in volts, and I is for current, measured in amps.
Question 2. When a new venue has been built and new machines are problem-solving skills do you use to work out which machines will fit where?
Problem-solving skills needed are planning whether a machine will fit into a certain area. We consider the dimensions of the machines, then factoring the height of the ceiling and the size of the area. Simple arithmetic to work out whether the machines will fit.
Question 3. When maintaining or adjusting game settings, how do you utilize maths to balance gameplays?
An example of this is our skill testers. We use a formula to work out the payout setting on a machine, as a machine only understands how many credits it needs in order for it to pay out. We use the formula factors in three things: the cost of the product, the cost of how much it is for each credit to play the game, and the desired percentage needed. This formula, using division and multiplication, allows us to know how many credits we need to enter into the payout setting.
Great. Question 4. How do you analyze the number of plays for each machine? Do you use any mathematical methods to assess which games are most popular?
We have a revenue report that analyzes the revenue of each game. This way we can work out which games are more popular, so we know which machines we need to prioritize for repair.
Thank you, Chris. Now let's go and revisit the mind map. After the interview, I then reflected on my previous mind map and I added in green the math concept that Chris uses in his job. I have ticked in green also what was mentioned in the interview and crossed in red what was not mentioned in the interview. Let's move on to the maths task. Chris's job today is to find out how much revenue the 3 pinball machines make weekly. Chris has collected data that on a daily basis the pinball machines play an average of 85 plays. The cost of each play is 75 cents. What is the total revenue generated for all 3 pinball machines weekly? Now let's work out the answer. First, Chris will need to calculate the revenue for one machine. He'll be using multiplication to work out this equation, starting with the daily revenue for one pinball machine. Step 1. Daily revenue for one pinball machine. 1 times 85 times 0.75 equals $63.75. 2. The daily revenue for 3 pinball machines. So you will take $63.75 and times that by 3, which is $191.25. And now to work out the weekly revenue for all 3 pinball machines, we will take the $191.25 and we'll times that by 7, which will get us $1,338.75. Working on the investigation of revenue generated by pinball machines has significantly enriched my understanding of mathematics as a practical tool in the workplace. Mathematics was essential in various operational tasks such as diagnosing machine faults and calculating revenue from plays. For example, using the formula P equals V times I for electrical diagnostics, which highlighted how mathematical principles are integrated into technical problem solving. The mathematical techniques were very simple. Rather than complex equations, basic arithmetic worked fine for this task, like evaluating machine fit and revenue estimates. This reflects Brown and Porter's point about the importance of practical mathematics in the workplace. It shows how basic knowledge can give us some empowering knowledge in day-to-day business. Mathematical knowledge plays a crucial role in fostering meaningful engagements in society. Through analysis of revenue reports, businesses can make informed decisions that enhance customer satisfaction, demonstrating the real-world significance of math literacy. Gainberg notes that practical mathematics skills empower individuals and organizations, underpinning effective participation in today's economy. This experience also closely relates to the mathematics taught in schools. The arithmetic, percentages, and basic math skills emphasized in the classroom have direct applications in business environments. Besot and Ridgway highlight the importance of connecting classroom learning to real-world scenarios, while Hay suggests that students should learn mathematics in context in order to be better prepared for life after high school. Overall, the research has helped me realize how essential mathematics is in both a professional and social context, and how much it can be applied to practical decisions. Thank you for listening.